Hello, yeah, looks like we're live. Awesome. So, hello everybody. Thanks for joining for today's live stream. This is the fourth part of our serverless search engine, serverless live project that we've been building over the last couple of weeks. And it's been a bit of an up and down battle the last couple of weeks. But today we're hoping to finish off at least to a point where things can kind of be left to, the viewer's discretion about what they want to edit and so on. Just want to make sure that everything on the stream is running fine. Seems good. Okay. So just to catch up anybody who might not have seen the other parts, if you haven't, there are 3 other parts before this, if you want to go through them. If not, let's just do a quick catch up. Basically, the project that we're building is what I call a serverless search engine. So the idea here is that we have a multi-service serverless project that we've been building over the last week or so. And we have a few parts of this. So the first part is a front end that is just basically a search box where you can type some keywords in. The next, and this is hosted in an S3 bucket. Nothing fancy there. The next part is the query service that we did in the first episode, which was the beginnings of storing data in a DynamoDB table that we retrieve on a search query. If somebody enters text into that search box. And that's all that the query service does. It just pulls stuff out of DynamoDB and displays that to the user on the front end. And then sort of the major backend portion was this spider service that we created here, which is meant for essentially trawling the internet, doing the HTML scraping of pages, just like a search engine spider would. So the spider service will go out and pull the HTML for pages, scan them for content that we want to use to index, and potentially other links that we want to go then later pull data out of. And then once the spider service has grabbed, sort of indexed a page and gotten some relevant keywords, it's going to send that via SNS to the query service. I think it was SNS to the query service, so the query service can maintain its data store of search queries that it can perform. So I'm just going to take a look at that to see if I'm right. And it looks like, let me just make this a bit smaller. Yes, it looks like we have this SNS commented out, otherwise it can't deploy if we're referencing a SNS topic that doesn't yet exist, because we haven't actually created this yet in our spider service. But we may not even get to this. Today, really, all I want to do to sort of wrap up this project is to take a look at our spider service and finish up some of the missing bits and pieces. And what's really missing here is our scraper isn't 100% complete. So last time we were spending a fair amount of time looking through our serverless.yaml file and correcting a lot of the parameters here. This is actually useful knowledge to know, where you can use something called variable syntax, so that instead of having to worry about how you can access these variables for AWS, you can assign a variable syntax here, which basically says any serverless.yaml variables need to have the double bracket, and anything with a single bracket can then just be your AWS variables. A very useful way to do this, so that you can just include your references to AWS variables. Makes life a little bit easier. And then we set up some IAM role statements. We started looking at setting up environment variables, as well as an FN sub here to add the SNS topic. And what happens is that we have 2 functions right now. The one is called start scraping, which runs every hour. And the plan with this, and it doesn't do it yet, but the plan with this right now, it's just hard-coded that it's going to send a message via SNS. That's all we wanted to test. But the start scraping function is going to execute every hour. And what it should be doing is looking into our DynamoDB table of URLs to scrape, grabbing 1, 5, 10, whatever batch size we decide on for our own scraper, and then sending each of those URLs that it extracts via SNS to the scraper function. So the idea there is, the reason why we do that is because if you're extracting, say, let's make a batch size of 10. So if you extract the 10 next URLs to go scrape for, you loop through that array of results, and you can send each one individually as a separate message into the SNS topic. And then you can have potentially 10 scraper instances of these running in parallel. So that's pretty cool. You make use of that parallelization of Lambda by using SNS to help you get however many scrapers in parallel you want running at the same time. So you could potentially up that to 100, 200, however quickly you want to go through this batch. And of course, you can then adjust the start scraping. So here you can, here it's set for an hour. Oh, let me adjust that. Here we just set this for an hour because we don't need more than an hour. But if you're going into production with this, you can set this for every 5 minutes, every minute, however often you want to go running through the scraper portion of this. So this setup gives you a nice sort of flexibility in how you can manage that. You can choose the rate at which you start the scrapers running, and you can then set the batch size in code about how often you want, or what size of batch. And there's some nice adjustments you can make to this. So if you want to, for example, have a central way to control the batch sizes, this is possible because you could do something like set up here const batch size is equal to process.env.scraper batch size, for instance. And this batch size, this scraper batch size, can be in our serverless.yaml file. Make this an environment variable like that. But we use Serverless Framework Pro, so I'm going to go ahead and make this a param with the same key value. So what this means is because, and if anybody's not aware, we've been using Serverless Framework Pro to help us build all this, especially with a feature called Studio, which helps us, which we'll take a look at in a minute. But what this param now gives me, and I just need to confirm, is it params or param? Let me just check that quickly. Parameters, it should be params, I'm going to say. Where is it? It's here. Oh, it's param. Okay, so I was wrong. Let me correct that to param. So what this means is I now want the scraper batch size. I want this needs to be replaced at deployment time. So when I deploy my code, I need to have an actual value. I mean, obviously that's a variable. So the value of this variable, because it has the param syntax here, I was going to point at the screen. It has the param option here. Serverless Framework knows that this param refers to the deployment profile in my Serverless Framework Pro account. So let's go there quickly. If I go to my deployment profile, my org settings, deployment profiles, I am using this. I've just got one deployment profile for now. If I was going into production, I'd create a second one to point at a different AWS account, potentially, or whatever. Let me just edit this though. And for now, I'm going to set this param to be scraper batch size, and I'm going to make my batch size 1 because I'm in testing. I don't really need to go for anything bigger than that. So the usefulness for this is now when I do a deployment, it's going to go to my Serverless Framework Pro account that is connected because I did a login. So let's go back to here so we can see this. Oh, and this is Studio that's connected. So I'm going to actually disconnect for now from Studio so I can show you this. But because I did an SLS login, and let me just clear SLS login here. This would open up my browser. I'm already logged in, so I'm not going to do it again. If I ran this now, it would open up my browser and connect my CLI to my Serverless Framework Pro account. And because my serverless.yaml file has app and org settings, which points to, so there's the org, which is serverless search engine, and the app is search engine. So if I go to my apps, search engine, just a way to reference that. And why this is useful is now I've got access to things like all of my debugging information. So earlier I was just kind of getting set up and just seeing where we were at, where I left this last week. And I just was taking a look to see, for example, I was having some errors, and I can now, here I can go see my CloudWatch logs. I can see here's a request to serverless.com, which I'll take a look at in a second again. But yeah, I've got all my logged information that I needed. And so on, so pretty useful stuff. Anyway, so we'll take a look at more of this. So I'm just going to connect Studio again. So what we've been doing over last week and today as well is that because I'm going to be working on Lambda code, I'm using a feature called SLS Studio, which basically does a deployment into the cloud for me, so that I can test my Lambda functions in the cloud. And Studio will also then watch my Lambda functions for changes. And every time I save a change, it's going to update the Lambda function in AWS within a few seconds. That means I can make a change, save, updates, test, make a change, save, updates, test. It's a nice quick way to do my testing without having to worry about all my local emulation and so on. This initial deployment, though, is a regular deployment, so that takes the usual 1 minute or two. All right, a lot of stuff I was just talking about there in the first 10 minutes of the stream. So if anybody is here and would like to ask any questions, so the whole point of these sessions isn't necessarily just this project. If there's anybody here that has questions to ask, has something they want to know about serverless, any question you like, whether it's about the project I'm busy building on the screen or your own project or the framework or anything at all serverless related, that's what we're here for. Feel free to ask in chat. I see we do have a couple of people here. Thank you. Hi. Hello. Hi. 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 So yeah, while we continue, where is the stack that you're referring? I'm not entirely sure what you mean, CodeGigs. Hey, Zaki. Nice to see you again. Just waiting for Lambda Studio to get going. Sorry, CodeGigs, I'm not sure. Account. Where is the stack that you're referring? I'm not necessarily making my deployment accessible to everybody, if that's what you're referring to. So, yeah. All right. So let's continue a bit. And now I'm going to go ahead and let me actually close. Let me go find my start scraping. No, I want the scraper. All right. So what I'm going to do is now I'm going to keep that open and close that so we can see the stuff together. Okay. So the only thing that I've done sort of off screen was just reference the correct data out of this page. So let me just run through this again for folks who haven't seen this before. It's been a little while as well. So the idea here is that this scraper receives an event from SNS. AWS variable, yes. So yeah, exclamation ref basically tells CloudFormation to replace that with the actual account ID you're making a deployment to. So you don't need to hard code it, which is a great thing to point out. Let me just go through that again, CodeGeeks. Thanks for pointing that out, because what's useful with let's take a look at this in a bit more detail. So stuff here. So I put this is here originally because last week we were busy experimenting with different ways to reference account ID, region, all that kind of information. So we were trying to add this into the custom section. So we could use, for example, we could have then used something like self custom dot account ID to reference the actual account ID, but we changed that. So I could technically remove this. I'm just not going to at the moment. Technically I could, because what we've done instead is we have a section here now where we have just straight up account ID. But what you may notice is that the serverless variables that you would normally have with a single curly brace has now a double curly brace like here. And the reason for that is that the reason why getting access to AWS variables is often tricky is because of the fact that the serverless framework tries to do a single curly brace as well. So the CloudFormation syntax that then tries to replace the region here gets captured almost by the serverless framework's attempt to replace its variables. But as you can see, I've got a double curly brace here, and that's because of this variable syntax here. So this variable syntax here is telling the serverless framework that this is what my variables will look like. So it's kind of replacing the built-in single curly brace version with a double curly brace version here. Okay. So this kind of simplifies things, but complicates it a little bit as well, because the complication is that anybody who's who's built serverless framework projects before is now going to come in here and see double curly braces and might have a few questions. That's unfortunate. But what it does do is it means that accessing the AWS variables like region and account ID, and even the references to other resources that we might end up creating in the resources section, becomes a lot simpler to do, which is often a good thing, which is what we decided to go with. So we just replaced the serverless framework variables with these double curly braces instead. So, yeah, your decision as to how you want to deal with that, to be perfectly honest. Okay. So I hope that helps answer questions. But yes, ref AWS account ID is one way to do it. We just decided not to in the end. Okay. So just back to Scraper. So what I was saying is that we have this Lambda function called scraper is going to receive and is going to be triggered by an event from SNS. So my event object here is going to be SNS related. And that means and here we were just logging out the event object to make sure that we were passing the right event data and so on, looking at what the records look like internally. This is all while we're busy testing and so on. So I'm going to remove this now because we actually don't need this anymore. We sorted that out last week, so we've got all that information. I'm also going to remove this, but I'm actually going to add a login here for the error, just so that we have some kind of error log if this happens to hit an error. This should never happen, really. The event object, because it's being triggered by SNS, it's connected to an SNS topic, it should never not be an SNS event. If it is, then obviously that's a problem, and that's why we do this, just in case. But technically, if we hit that, there's bigger problems. AWS is sending us the wrong data to begin with. So, but okay, we're just covering our bases here. And what this does is, so the benefit of doing this is that because SNS is a pub sub system, it will receive messages from other parts of the system. In this case, the messages are going to be coming from this Lambda function, start scraping. But the advantage this gives us is that SNS can now do the error management and retries, which is pretty cool. So we don't have to worry about any of that. SNS receives the message from that start scraping Lambda function, and then it'll try to propagate that message into, it's updating because it's saved. So you can see there is Serverless Studio now is busy updating the function because my IDE auto-saved. Anyway, so SNS will try and send the message to this Lambda function that is subscribed to the topic. And if this Lambda function came back with an error, SNS would decide, okay, I'm going to retry in X amount of time and do that. So it'll hold the message, try it again. If it fails again, it'll hold the message and try a second time. And if it fails the second time, it'll try one last time. And that's where it ends. And each of those retries is slightly longer than the previous one, so it'll have a bit of progressive back-off. So technically speaking, the retry system is nice because maybe we just had some transient network issue or something like that, and then it'll just end up retrying, and most of the time those problems will be solved. But let's just say, worst case scenario, we have a Lambda function that's actually got an error. We deployed this function, and it's going to always throw an error because something's wrong in our code. That SNS topic is going to try 3 times and then drop the message. That's just the way SNS works. That's how it's designed. We need to know this so we can handle that. So one way to do that, we're not going to do it now, is to do a dead letter queue with SQS. So you can actually set that up. And there's some great documentation. Let me just find this documentation for SNS. Hang on, dead letter queue. Yeah, here we go. So I'm just trying to find where the dead letter queue is. Permissions, VPC, environment variables, tags, layers, log group, versioning. Dead letter queue. Here we go. So, for example, if your function throws an error, you can then drop it into SQS. That's annoying. I forgot about this. We unfortunately don't support dead letter queue with SQS, but it means that you can then use SNS to drop it into another into the on error dead letter queue that you can then process with a generic Lambda function that handles errors that can then stick them into the right SQS queues and what have you as you need to. So yeah, you can then make sure that you capture all these messages, you don't lose them permanently, which is always a good thing. Anyway, so let's get back to this. Diverging a lot, but I like talking about these things. I like folks understanding why we're choosing the technology that we are. Okay, so SNS is great for that, and if anybody wasn't here in the beginning, SNS is also going to be able to help us handle our batch sizing and so on of URLs that we're sending to the scraper function. All right. In our case, we're always going to have only one. So you can see here, I'm checking that the length is greater than if event records is not an array, or records of length is less than or equal to 0. In other words, the array is empty. Then it's going to throw this error. Otherwise, we're going to grab the first record out of records because we're always only going to have one. The start scraping function is always only going to send one message. There's never going to be multiple messages. So we grab the first one always. And in our case, we're just a scraper. If there happens to be 2 messages, who cares? It really doesn't make any difference. If there's 3, 4, 10, we're just scraping out of a list of URLs. This isn't some high productivity environment that we need to make sure we handle every possible message that comes through. If that was the case, we would loop through our records instead. So this is fine. This keeps it simple. And the messages contain a property called URL. And then we grab the URL that's sent from the start scraping Lambda function. And we then use Axios to go and get that URL. And once we get that URL, we can then grab page data. So here, actually, I want to go page data. So we grab the page data, and this is also console log, and I'm going to remove this because we no longer need this. We know that works. We don't need to error out on that. What we do want to do, perhaps, is do a try catch block here to catch any errors. Page load error. So I'm going to log this out and say there was a problem loading the page. And I believe my daughter is joining us. One sec. Yeah, we had an arrival of my daughter. Alrighty. So there was a problem in the page. Then we want to log out the error itself. And I normally like to log out the name of the variable so that I always know what variable the data actually comes from. Can an SNS subscriber be a step function? I think that has been a recent change that allows that. So let's take a quick look. Call Amazon SNS. No, so you can call SNS with step functions. Obviously, it's just a Lambda function, so you can call SNS. That's nothing crazy. The thing is, actually, it doesn't matter. I'm just thinking it through. Ultimately, what's going to happen is your step functions is going to call a function, a Lambda function. So your first element in your step function is going to be a Lambda function, usually, 99% of the time. And yeah, just fixing that. There we go. So the point is that if the first step is going to be a Lambda function anyway, SNS might as well just call a Lambda function that's going to start your step function anyway, because that's kind of what is going to happen, if that makes sense. You're going to have your first function within your step functions is going to have to be some kind of bootstrap to get to put data in and prep data, potentially things like that, and to kick off the next step in your step functions workflow or your flow. So it might as well just be a Lambda function anyway. So it actually doesn't make any difference. Hope that makes sense. The point of step functions is not necessarily to asynchronously trigger from things like SNS and so on. Step functions is to coordinate the flow of data between your Lambda functions. So you might as well just have SNS trigger any old Lambda function that then kicks off the rest of the step functions flow. Okay, hope that makes sense. Okay, but SNS is an incredibly useful tool. I love SNS as a way to pass data asynchronously. And EventBridge is another very awesome tool that I'm trying to use more of. I just tend to use SNS in these kinds of situations because I like to. I'm just familiar with it, and it's a nice quick way to get things up and going. I understand that. I guess the best way to think about it is it's always not. I like the idea just off the top of my head of having a Lambda function that kicks off a step function's state machine, because it allows me to just essentially prep everything I need for my state machine before I start going to that state logic. I hope that makes sense, because SNS, I mean, SNS is a very specific event object. It can pass a message, but it's got a very specific SNS structure. So the ideal is not to necessarily have SNS pass an SNS event object into a state machine, because that's very SNS specific. You can't reuse that state machine in that case. You can't switch to SQS or Kinesis or anything like that. So to have that Lambda function ahead of time, that's essentially going to do an ETL on your event object to make sure that what goes into the state machine is shaped to that state machine flow specifically. I think this makes it a bit cleaner generally. Anyway, okay, so we've got this working. So if anybody's wondering what Cheerio is a tool to let you load a page. Oh, and by the way, Zaki, I don't know if you've noticed I've turned low latency mode on. I don't know if it's making a difference, but anyway. So Cheerio is a tool, an NPM module that allows you to essentially load HTML and then access it like you would with jQuery, which means I can use the sort of dollar syntax that you're familiar with jQuery to then access all my nodes in my HTML page, which is great. It makes it very easy for me to then go through this page and find the data I'm looking for. And what we decided last time was to go looking for, first of all, we need to find the links in our page, because that's potentially targets to scrape in future. And we need to index content. We need to generate some kind of search index for this specific page. So, you could do vastly complicated things, Google style algorithms. This is obviously meant to be a simple project. So all I'm going to do is, first of all, let's try and get our A objects, and let's just go take a look. Just to remind me how Cheerio works. The basics of Cheerio is we want to grab let's just see where with selectors. Okay. Here we go. Okay. It's been a while since I've used jQuery, so forgive me while I just do a little quick refresh. Okay, so this is going to grab the text out. So what I really want is the href attribute out of my A-links. Okay. So let's go back here. So what I'm going to do is this is going to be my links array is e dollar a, just all the A's really, dot attribute, and this is going to be the href attribute. So it's going to pull all the href attributes out. That will do we'll do an array, right? Within the context scope. Okay, cool. So I'm going to do that, and then I'm also going to do h1s. So let's pull all our h1s out. Heading 1. So that's going to be, I just want the text out of that. So I want to potentially index my h1 text. So let's pull the text out. And then I'm going to log these out so that we can see links, what my links look like. And then I want to see what my heading looks like as well. Oh, nice. Nice to know that low latency seems to make a difference. All right. Heading 1. Okay, I just want to make sure, so we can see here, Serverless Studio is updating my Lambda functions as I'm saving. I tend to save really often every time I finish a line, which can make Serverless Studio a little paranoid or not update as often. There's a sort of a debouncing timeout feature in the update mechanism so that it's not constantly pushing updates into AWS. I think mostly because AWS does have kind of limits as to how often you can update things like that. So I'm just waiting to see. This update is taking a little bit longer. This might be the exact limits I'm talking about now that is making it slower. But what we could do is now, because it's updating into the cloud, it means I can switch to Studio here and actually test this. So luckily last time what we did, so this is Studio for anybody who hasn't seen this before. Studio is kind of like a Postman style interface. Cool. So Studio is kind of a Postman style interface so that I can, here's my Lambda functions that I have in my serverless.yaml file. This one is invoked using SNS, but I can pass an event object myself. So here is a manually created, simulated SNS event object I created. And if you happen to have one that's connected to API Gateway, an HTTP event, then this will give you an actual HTTP style interface like a Postman, so that you can enter a body, headers, all the other stuff that you might want for HTTP. In our case, we have an SNS object that we're passing. And here we're passing the URL, serverless.com. So we're just using that as our little test URL to play around with. And it's updated. So I'm just going to send my little test. Let's see what our logs come back with. Okay. Dollar is not defined. So we have an error to deal with. Scrapper.js 2417. Oh, do this because I tried to do this before, but because I'm in a try catch block now, it's not going to work. So let's update that so we don't have that error anymore. And you can see I'm also getting my errors into my terminal here. So because I got an error when I executed that in Studio in my browser, it's throwing the error out here in my terminal for me to see as well. Kind of handy. So I don't have to rely on that log. So it's just busy uploading the function. This takes a few seconds. Not sure why this is taking so much longer than usual. Oh, and one thing to mention is Studio is in beta. I'm sure you saw that little label. So the team is busy making changes back and forth. There are probably some bugs still, which is why there's this beta flag on it. But there are some significant updates coming soon, and I'm hoping they'll be going into general availability with Studio soon. It's one of my favorite features of the framework so far. Completely, what's the word I'm looking for? Game changing when it comes to building your serverless applications. Yeah, so usually this takes 3 to 4 seconds. That took a little bit longer than usual. But let's just clear our old log. Let's send another one. I think it looks like we're not getting the data we expect. So I'm going to just take a look at this. And then maybe even... Yeah. We are getting... So let me actually go, I don't know. Right, so this what we see here might be an artifact of Studio. So I'm going to go look at my actual invocation. So using Serverless Framework Pro, I'm actually going to look at the invocations that were made on my endpoints, on my functions, sorry. So let's switch to functions view. I'm only interested in the last 15 minutes or so. Let's see. Let's just wait for this to update. We should see, so this is from 1232. Yep. We should have a function update. There, that one. That's the one we just ran. Is there an error here that we're missing? No, there isn't. It's just links. Okay, so there's something logical that we've obviously done wrong. Let's go take a peek. Okay, so I'm just going to clean that. Interesting. I'm going to just try, let's just do that without, let's just pull all those DOM elements and just log those out and see what happens. Interesting. I'm trying to think if there's anything I might have done wrong. It seems like it should have worked. Don't know. I've been referencing it wrong. Let's just take a quick look at Cheerio documentation while it updates. So that's .html. Is it because there's more than one? Maybe that might be it. I might have to pull A and then loop through each and then do. Okay, I might have to do that. So let's just wait for it to update quick. So basically what I'm saying is that when I doing these, it's going to pull all the A links, and that's going to return an array of links. But by doing a dot attribute, now the array doesn't have an attribute of href. Each individual item does. So I might have to do a dot each. I don't know if it does that. Oh, it does. Okay. Wow, really getting back into JavaScript's the JavaScript ways. So let's go take a look at what that looks like in Studio. So I'm just going to clear that old log, send a new one. Let's take a peek. Interesting. I think it's going to be an array. That's the problem. So, oh yeah. Oh, there we go. Okay. Yeah, there's a lot of content there. Wow. Okay, there's actually quite a lot of stuff about A-links. And oh, it's an object. Oh, okay. All right. So that should have worked actually, if I think about it. Unless and look, there's href. Oh, it does the first one. That's the problem. So it pulled the first one out and then stopped there. It didn't pull out anymore. Okay, that makes sense. All right, so let's go back to our code. So for the links, let's do. Can I do .map with this? I don't actually want to do that because that's going to make it asynchronous. So let's just do. Trying to think this through. Let's go take a look at Cherry and see how, because we're doing things asynchronous. This is different. We're not doing things with the callbacks and promises. Except here it's saying, oh, it gets the attribute for only the first element. Okay, so that was right about that. Gets the property value for only the first element. Okay, I want all of them. Only the first element. Val has class, add class, remove class, toggle class, is, forms, don't care, traversing. So it's going to find descendants. I'm not really, don't want descendants. Don't want closest, next, previous. What we want each. Yeah. This makes this look synchronous. It can't be. This is a callback here. Okay, this is really what I want. What I would have wanted. It actually doesn't matter. I can do that. All right, let's do that. Let's just map over it. Okay. So what that means is that links. So what we want is the link URLs are going to be equal to await on links. Whoops. Dot map, and this is going to be one link. It is just that, yes. Okay. So if I just do a $link, let's just take a look. $this. I might not be able to use that. Might not be able to use arrow syntax because of the way it handles this. Dot attribute dot href return. Okay. So it's going to return that. That'll be that should be good. I'm going to do basically the same for the headings. Oops, I need to do that after the headings. And I'm going to make this heading text, a single heading, this dot text instead. That should do it. Let's let it update. So code gigs, I'm scraping a website, and the idea that this whole project is about building a serverless search engine. So we're at the point now where we're looking at scraping HTML pages, and what we've decided, just as our idea for this scraper, is that we need to extract the links to other pages so that we can go to them and scrape them. So that's why we're doing this here. So we pull the HTML for a specific page, we yank all the links out, and then we're going to add that into our database to go scrape later. But we also want to index the content of the page like a search engine would. So we're keeping it very simple, but you can go absolutely bananas with your indexing algorithm. But for now we're just looking at the H1s and adding those into our database for when there's a query that comes with the H1, with the content of an H1 like a heading. So now that this is updated, we should. Oh damn! I need to change these to be that and this. Otherwise, we're never going to see the result in our testing now. Let's just update that again and watch that redeploy quickly. So I hope that answers the question, code gigs. Right now, we've hard coded the value that we're testing. We're just scraping the serverless.com site as our test platform. Limit the depth of? No, I'm not. Right now, I'm not. I'm just grabbing URLs and I'm going to stick them in a database. What we are going to do though is mark something as scanned or with a date, and when we add them into the DynamoDB table, it'll have a. Okay, I'll get to that. We might not have time to actually implement that piece, but it's a very interesting thing that we can do, which will automatically help us maintain the state of our sort of scraping database that we're going for. So let me go back to Studio. I'm just going to clear this test out and try another one. So you can see here our test data is just testing serverless.com for now. Oops, it's not. Oh, that's weird. There, serverless.com. And do we have what we were looking for? Yes. So there's root. There's /open source. Oh, interesting. So this is something else that we can. Okay. So this gives us some interesting stuff to do because now we have an external URL. Okay. It's nice to see how this data comes in. I might. Okay. So now the other thing that we're going to do now, because those are our links. Let's take a look. Those are our links and our H1 that came in. So what did we get here? Oh, we got the entire H. No, we asked for text, and it didn't give us the text of the H1s. Looks like we had no heading text. Maybe the serverless.com page doesn't have any headings. Let's just take a look at our more detailed logging information here. Stop doing that. So it was what, 12:43? There it is. Okay, I can take a look at that. Let's just let it update. Should have been that one, I think. Okay, here we can see this makes it a bit clearer. So you can see there's all of our URLs that we extracted. Nice. With a bunch of other stuff attached. And the mail too. So you can see how easy it is for spammers to just go yoink these email addresses out of whatchamacallit. Oh, it's got each individual one. Wait, it's because we still logged out the Nope. Okay. Let's just keep going down, 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 down the log. Those are a lot of links. Come on. Okay. So heading text. Guessing there weren't any H1s. First time I've seen that. Let's just go back to serverless.com. Look at the code. Where is that H1? Where are you? Oh no, that's in there. That's in there. That's in CSS, it looks like. Oh, for goodness sake. That's an H1, right? No, it's not. Okay. Gatsby. Oh, okay. So maybe that wasn't the best page to try and grab H1s from. Wonder if the docs are a bit more standard. Inspect element. Yeah, there we go. All right, so what I'm going to do is I'm going to grab this URL instead. Let's go back to Studio and use that. Let's replace. Oh goodness. Let's replace that with that. Clear our tests out and send that. And let's see what happens. Did you update? Yep, I did. Did update the console log. Oh, jeez. Send another test. Studio's not showing me the results. I'm going to go here, take a look. So that would have been, yeah, 1247, makes sense. That would be the one I need. Let's go look at those logs. Yeah, so that's the right page. Let's just continue down. A lot of links, they docs, so there's going to be lots of links in the docs. Let's just scroll through like this. Okay, so this looks like I may have, oh, there we go. Yeah, we go. Serverless framework documentation. Heading 1, serverless framework documentation. Okay, so we are grabbing that. Nice. Okay. Yay! So that is working. All right, so now that we've gotten ourselves some documentation, what I want to actually do, so there are objects, I need to store them. JavaScript. Try to remember what the own property is. The is own property. So what I'm doing is I've got an object, but it's also got all the inherited properties, or inherited properties of an object. And what are we doing? Okay, object.values. Right, so object.values. Okay, so that means in our code, I can make this object.values, and here yeah, because it's prototype inheritance, it's inheriting the value, all the other properties of the general prototype objects, and I just want the values. I just want an array. I just want the list of hrefs. I just want the list of heading text. I don't want the everything else. I'm just letting that do that, and then what I need to do is I need to go through each of these and store them. So think about how I'm going to do this. So we're going to use DynamoDB for this. So this means I need to go and add some DynamoDB definitions in my serverless.yaml file. I'm going to close that so I can see this a bit more. I'm going to start adding a DynamoDB table. All right, so let's go take a look at what that looks like. So I'm going to go through my process of how I add these CloudFormation entries as well. I did this in I think part 1 as well of the series. But basically, I use the CloudFormation documentation to help me this, and it's actually really useful to do this. So here, for example, I've gotten the CloudFormation documentation for DynamoDB, and this you can just find this by going CloudFormation DynamoDB, and it'll give you this DynamoDB table syntax information here. And what this means is I can now embed this table, a table with this these properties in my serverless.yaml file. So every time I deploy, I'm always going to have this DynamoDB table with this service specifically. So to start off with, I just go through these sort of line by line. So the first one I need is going to be this sort of literal, which is going to be, first I need to give my DynamoDB table a name, and this is going to be URLs table. It's where I'm going to store the URLs that I'm going to be scraping. So yeah, the first part is type that I copied, so I need to put that in so that CloudFormation knows what I'm doing. I'm then going to do properties, so let's copy that out, and then let's do attribute definitions. So go to attribute definitions, I click on it to go through, copy that as my next line, and I can see that it is a list of attribute definitions. So we're going to have an array of type attribute definition, and this is what it looks like: attribute name, attribute type. So array, the attribute name, and this is going to be URL, the attribute type, and this is going to be a string, and then I'm going to do it again, and this time it's going to be added timestamp, and this is going to be a number. Okay, so now that I've finished with that, I can go back. I'm going to go back again. So attribute definitions is done. My billing mode, what billing mode am I picking? I'm going to go with paper request because it's just easier. So first of all, billing mode, let's copy that, and then I want the value paper request. It's basically on-demand mode. Yep. So the next item I need to go with is, oops, too far. Global secondary indexes, I don't need any. I have no global secondary indexes I need to make use of, so that's all good. The key schema, I have to define a key schema. That's part of DynamoDB. So let's go key schema, and this I know is an array as well. So you can see list of key schema. So I'm going to go look at the definition of that item. So the attribute name is going to be URL, and this is going to be, this can only be hash or range in the documentation. So let's grab hash, and the attribute name is going to be URL, and this is going to be hash or range in the documentation. So let's grab hash, and range in the documentation. So let's grab hash, and range in the documentation. So let's grab hash, and range in the documentation. So let's grab hash, and range in the documentation. So let's grab hash, I'm going to copy this again. And in this case, this is going to be my added timestamp instead. And this is going to be my range. All good. So the reason why we also added timestamp isn't only for to be the range key. We want, and I'm gonna, maybe I should leave it until we get to that part in the YAML here. So I'll do that. I'll get to that in a second. All right. So we've done key schema, local secondary indexes. I don't have any local secondary indexes. I don't need any other indexes but what I've got, URL, and updated that basically. Point in time recovery specification. I don't need point in time recovery. I don't really care. This is a transient table. It's going to contain data. I can lose this data whenever I like. This isn't ultra critical information. This is just a list of pages that I potentially want to go scan, scrape for indexing purposes. So even if worst case scenario, this entire table dropped, kind of doesn't matter. I can just start rebuilding the list from scratch. Provision throughput. Because I'm on demand, I don't need to worry about provision throughput. Provision throughput is how much capacity to give my table. SSE specification, I don't need that. Stream specification, I'm not doing any DynamoDB stream stuff, so I don't need that. My table name, we're going to do table name, so let's go to table name. I always like to name my tables myself because that gives me control over what the name looks like as opposed to just some dynamic random name. And I normally name this specifically in a way that identifies it as a part of this service and as a part of the stage that I'm deploying to as well. So self service, I just start with that. So it'll always be, so this service name is Spider service. So it'll always have Spider service in the front, which is great because I might have another service that wants to be called URLs table. Otherwise, I'm going to say URLs table. I'm just going to say URLs because it's obviously a table. Don't need to say that. And now I'm going to add on the stage. And by default, I'll do dev. So the stage that it's being deployed with, if no specific stage was allocated, it's going to just use the default of dev. Okay, so that's table name. Next one. Let's go back and take a look. Table name, cool. Tags, I don't have any tags. Technically, if you're going into that could be useful, code gigs. You're right. You could possibly use a secondary index to yeah, you could if you wanted to rescrape. I'm not assuming that at this point. Like I said, this isn't meant to be like the ultimate in a search engine. This is kind of just an experiment that we're doing. We're just playing around with serverless, seeing what the capabilities are like, how you can structure things and put it together. But secondary index definitely you could use as a way to specify a retry period. In our case, though, the plan is to remove these items from the table, and that's where we're going to be using time to live specification. So the idea with time to live is that because we have a timestamp we've allocated, the time to live specification wants you to choose a column, if I remember correctly. Let's just take a look at the specification itself. So you have to add, yes, okay, so the attribute name. So what you do is you tell it the attribute name of your table. And this is not a list. Yeah. So I'm going to go there. The attribute is going to be added timestamp, and it'll look for it as a timestamp. And enabled true. And what this does, if anybody watching is not familiar, time to live specification means that when the added timestamp is reached, okay, so I'm going to have to actually adjust this. This is not added timestamp. This is going to be scanned. So what I wanted to do was to have it just automatically be removed, so I don't have to pass a delete command, which costs me resources to do. A TTL removal is automatic and free. DynamoDB will clear things without cost. It doesn't impact your RCUs or WCUs to do a TTL delete. So you can actually, we can do a scanned timestamp. Okay, so that's what I'll do. Or scraped timestamp, let's just make it clear. So what scraped timestamp will do is going to, so this will be empty by default, so we won't have anything in here. Once we scrape it, we update the record with a scrape timestamp, and that'll be the current time, which means that the TTL will come out after that and remove it potentially. Yes, that is what I'm going to do. I always use environment variables for my table names as well. Okay, so that's basically what we want. Yes, I think that's all we need. And I'm just thinking now, funny enough, updating with a scrape timestamp is going to cost about the same as just deleting it ourselves. So this might not actually be the best way to do this. Because ultimately, I don't necessarily want to keep this enormous amount of data sitting around, consuming resources, costing me money in storage space. So, maybe I just remove this and just delete it when I'm done. Yeah, that probably... Well, this is where your idea of using a secondary index just to have a retry of a scrape would actually be interesting to do. Just as a tip, though, I would probably use a GSI instead of a local secondary index, because GSIs are a little bit more performant. No, they're about the same. Just thinking it through. Actually, so I'm just going to remove this, and then we're going to delete it when we're done, because why not? There's no need to overcomplicate this for this session, and you can, when you're building this yourself, you can then worry about what you might need. So we don't need a time to live specification then, because we're just going to delete it when we're done. So what that means is that this now needs to be added as environment variable, as you said. So if I go to my environment variables, I need to now add, and I have a way that I like to name these DynamoDB. So now I know the environment variable is related to DynamoDB. URLs table, and the value is that. Great. So let's just keep that together. And so we have ourselves a DynamoDB table. Let's go back into here. And now we want to store these objects. So actually now, doing this might not be necessary. We could actually just grab those hrefs and drop them straight into a table. And I think that's what I'm going to do. So I don't even necessarily need the await, because it'll, no I do, because it'll end execution here. So now just make Control-Z that. I'm going to drop that out and remove that. And instead of returning them, I'm going to do DynamoDB stuff. So let's just do a DynamoDB object is equal to new AWS. And do I have AWS object? I don't. So let's add our AWS. SDK. Oh, have I actually added AWS into my project as a dev dependency? I have not. So technically, I don't need AWS SDK. Technically, I don't need the AWS SDK because the Lambda function is going to have it by default. But you do usually, if you want to do like code completion locally, which I tend to like to do, I like to have my IDE do the auto completion stuff that it's meant to do. So I tend to install the AWS SDK as a dev dependency in the service itself, just so it's available locally and so on, and in testing. And that's the other thing. If you do end up doing testing with mocking of SDK and so on, you need that dependency because your test environment may not have it by default, like the Lambda service does. So I'm just going to break that and then do an npm i-save-dev AWS SDK. Let's just install that. So that should be installed. Yep. Let's just get Studio back up and running while we wait for that, and then I can go back here and I've added AWS SDK. and DynamoDB, new AWS dot sure, DynamoDB dot document client. I use document client because it's a simplified way to reference the DynamoDB methods and so on. And then I need to do a put param. And I'm not going to bother even checking to see if it already exists. Oh, thanks for that reminder. I always forget that. But you know, you get the error message, then you remember very quickly and you go and add it. So I will add that. Thanks a lot for the reminder. So I'm not going to go looking to see if something exists before I put it. If it does exist, the put is just going to overwrite it anyway. If it doesn't, and if it doesn't exist, it's going to put it in. So no difference. So let's do a put param. My table name is going to be that process.env dot. Let's go look at our serverless.yaml file. We need that environment variable. Sorry, there we go. Back to our code. We then just add the item, which is going to be, what do we call that column? That attribute URL, and that is going to be .toString. Just make sure that it comes back as the string, not a full object. And then we don't need to do, and we actually don't even need a map. It's not a map anymore. It's a for each basically at that point. Links.each. Yeah, because Cheerio adds the each function in, so we might as well just use that to loop through. Okay. That would do. I need to add the actual DynamoDB portion, so let's do DynamoDB dot put and await that. I can't await that unless I do an async over there. Put param dot promise. Right, so that, why doesn't it like that? That's probably it, because it's typo in Word. Don't care, that's how I spell it. All right, so that should do that. Let's go edit that serverless.yaml file and add those permissions in that you were talking about. So we already have here for SNS publish, so let's just go ahead and, oops, don't want to delete that. I'm going to copy that. Let's go home. Come on, there. Indentation. This is DynamoDB put, and this will be DynamoDB get eventually. No, query. And this will be DynamoDB. Let's just see that our deployment went successfully. Yep, it did. So it would have created our DynamoDB table for us. So this will be region. I want the table name. Let's go grab our table name. I'm trying to remember the syntax of the. So it would be the table name slash table. I'm actually just going to look off screen at my AWS account itself, just remind myself what that looks like. Because I do not remember. Management console. Oh, come on, AWS console, open up. Logging in. DynamoDB. Just remind myself about the AR, the syntax of the ARN for DynamoDB. Wrong region. While we wait, have a slurp of something liquid. Alrighty, tables. And this is sort by name, sort by name. Oh goodness, what is this service's name again? Spider service. There we go. There we go. I guess it didn't matter. I'm looking for the. Okay, so it's after the account. It's table. Account ID. It's table / table name. Cool. So that is that. I can remove that. All right. So now we have that. I'm going to redeploy Studio so that it can update all the permissions, because this is now going to do a full redeploy with all these changes in my serverless.yaml file. Unfortunately, if you make changes to serverless.yaml, it means the entire there's changes to the stack itself, so you need to do sort of a restart of Studio. This process as well, we're going to be we plan to optimize the way Studio handles the changes to serverless.yaml and the redeployment process. Right now, you do need to disconnect from Studio and then redeploy to get it to show those changes. And I have created an error. I am a doofus. Should be an array of objects. Oh, my syntax is probably wrong there then. Oh, it looks like I accidentally deleted something. Oops. Yep. My bad. That looks right. Let's try it again. Oops. True. I guess I should have just gone and checked there. All right. So again, if anybody has just joined us, this is not necessarily a session that's just about, this is not a webinar. We're not just looking at the project that I'm working on here. If you have any questions about serverless, about your own implementations, about any tooling, anything you want to know about serverless development in general, feel free to ask questions. This is what this is about. This is like a way for us to get together and chew the fat and talk about serverless stuff while maybe doing something interesting on the screen at the same time. And if you have any ideas for a future project for us to play around with, one of the ideas that I think Zaki mentioned is the idea of having a small little multiplayer game using some WebSockets. That sounds like an interesting project to me, actually, that I might seriously consider for the next Serverless Live series that we do. This is the last of this one, and we're probably going to end at around in the next 45 minutes or so to the next hour. So we got some time to do a few things until then. Right now we're just waiting for it to all update. There we go. That's finally updated. And we should have data going into our DynamoDB table now when we run Studio. So let's go take a look at, I'm just waiting for it to watch. Okay, that should be fine. Let's go to Studio. Let's do our little test that we did before. The same thing. And we should, well, we're probably going to get some errors. I'm expecting some debugging is going to be required. We will have to wait and see. My code is not necessarily going to be perfect. And I think what we've got here is, this is another thing about Studio, is that I think there may be a limitation as to how much data Studio can log out. So it's not actually showing us any of that data, or there's a specific error that is coming up. Yeah, there's no response coming out. I think there may just be, that could even still be executing for all I know. That is a possibility. I could be spamming my DynamoDB table something fierce right now. Okay, so let's go take a look in here instead. Let's go take a look at the logs in Serverless Framework Pro. Go to the Explorer. I want to see my functions in the last 15 minutes. The last one should have been around 1:15 for me. There, 1:14, that's probably it. Timeout. Oh, ran for 6 seconds, yeah. So it's taking some time. Huh. May want to switch that. What on earth is that, Saki? A caterpillar. Okay, crawling. Oh, crawling. There you go. Well, it's not actually crawling right now. It's got one URL that it's scraping, and it's going to yank out other URLs and add them into DynamoDB. So I'm expecting there actually to be data in DynamoDB right now. I have to go look at the table just to go see quick. And I'm waiting for the console to load because for some reason I decided to close that tab. I'm actually going to open it up over here rather, so I can keep an eye on the stream. And then let's see items. Right, there are no items in our database, in our table, sorry. So let's go remove that limit, the timeout limit. So the timeout by default for a serverless framework function is 6 seconds. That's primarily to help just protect folks from accidentally blowing things way out. So what I'm going to do is the timeout. I'm going to make it 30 seconds instead. Just redeploy that. So I'm going to make it 30 seconds rather. 30 seconds should be enough. If it's not, then we may need to just take a second look at what we're doing. I might just use I haven't actually ever used the batch put features of DynamoDB, and we may end up doing that. Let's just take a look at that while we wait. So batch write, I think it's just an array of items. It's really as simple as that. Yeah. So request items. Is this the table name? I'm guessing. Yeah, okay. Table name. You can do delete request, put request, so that's what it'll be. Okay, so if we have to, we'll do that, and then it makes it one sort of big API call as opposed to. I'm wondering, what is the limit? Batch write item. How many items can you batch write? Write up to 16 megs of data. 25 put or delete requests. Okay, so if we have more than 25 items, thing is, this doesn't save you any money. This is just potentially makes things a bit neater. And because I'm awaiting, that means I am actually adding each one individually, synchronously into the table, which isn't the best necessarily. So I may want to just change that up. Okay, but we've got the timeout up. Let's just. Well, I like to get things to a point where it's working, and then I'll go back and optimize after that, because I know I had a working system before I had a clean, well-running, optimized system, usually. So let's go ahead and just call that again. And let's let it execute. And as we start seeing information about the invocation, because remember, logs start going into CloudWatch before it ends. So here we can see page load error. It's because it ran for longer than 6 seconds, we now get to actually see link URLs is not defined at 3329. So let's go back to our code. 33. Okay, so it actually finished executing, but it errored out because we have this log here that doesn't have any data anymore. So I'm just going to remove that. It's going to update my code. And then we can run again. But that means that we should have data in our table now? No. Okay, something else happened, but because we didn't catch anything, it's basically just dropping the errors here. It's not doing anything with the errors. So we need to try catch block this to see what our problem is here. No, it'll. No, this wouldn't drop it. This should show an error. Let's go back to Explorer. 15 minutes. So that should be about 1320. I think that's the function there. Yeah, 6.1 seconds. Look at that. Just shy, just over 6 seconds. Okay, so here it went and got it. And here we go. Unhandled from access denied. So we do have, oh, my permissions aren't correct. If you put item, okay, I just messed that up. Yeah, like I didn't think we were going to get away without an error. So I need to update my permissions. Yeah, it's not just put, it's put item. And that means I need to, this is redeploying. Nice. No, that's not going to work. I need to just redeploy Studio. Yeah, but if the item, if the item was malformed, we wouldn't have seen that error message. So the error message explicitly was just about a permission error. We won't know about an empty item until we get an actual attempt to put it in without there being a permission error. I don't know if you heard those. Actually, the DynamoDB's made changes where you can send empty strings now as values. Thank goodness. I don't know why that wasn't a thing before. An empty string should be a string regardless. Yeah, so yay for that change. That's one of those things that in the past I've always had to add in some kind of ternary to check whether the string values I'm trying to add in is a blank string, and if not, turn it into some other string that I've got to go check, and then that was always kind of annoying to do. Now, yeah, very good news. All right. And if you hear the tortured screams of children in the background, they are perfectly fine, don't worry. The school is officially out this week, if anyone is not aware, in South Africa. For the next week, my daughter's school is no digi school this week coming. My wife's been doing most of the homeschooling for the kids, or for my daughter rather. My son's a little young for it. Okay. All right, so that's been published. Let's go take another look at Studio. And let's test that. Send the data. And let's take a look at this invocation. Give it a few seconds. Let's go back here. So we're looking for another one that was 1320 something. It's going to force a refresh on this. Oh, is it maybe executing too long? Oh, there we go. Now the logs have come in. Let's take a peek. Yeah, as soon as I look here, I can see immediately I don't have any put into DynamoDB, so I know something failed. Access denied again. What? Oh god, do I have my ARN wrong as well? My ARN. Alright, let's just close that while we take a peek. So ARN AWS DynamoDB. ARN AWS DynamoDB. DynamoDB region account ID. Oh poop. There it is. Yep, that's my mistake. So that's supposed to be table. Alright, so the ARN was wrong. Let's go ahead and redeploy again. Yeah, I've actually spoken to folks. There are going to be changes for Studio when it comes to redeploying based on a serverless.yaml file change. This is going to be a bit more improved, so it automatically happens, which is going to be very, very nice when that does come. Okay, so in the meantime, let's actually go take a look. Now that we've got the time, let's go take a look at how we can make this a little bit better. So instead of doing that, what I can do is I can await on a promise.all. I always forget the syntax of promise.all properly. It's basically I need let's just go take a look at an example. There's some really good examples out there, especially at MDN, I think it is. Promise.all. Resolve reject, that's what I'm looking at. Okay. I thought as much, but you know, I always like to just refresh a little bit. Resolve reject. Hang on, I'm going to just start on a new line so that I don't confuse myself. That's a function there, and I can close it there. All right, so now whatever is in here needs to return a promise, and that will be that. So I can actually take this in here. And this is just so that I can make it all parallel. I like to try and make these things, especially when I have a huge batch like this, go through and make it in parallel, but I don't want to continue the next section until they've all finished. So using promise.all means that I can just run through all of my promises here. Because I'm returning this promise.all is going to wait for each one of those to resolve or reject. And I can then do things like promise.all also has a way. If one of them fails, it'll catch the lot. Just trying to find the syntax again. It's here somewhere. Yeah, so there's fail fast behavior, as it's saying. Yeah, dot then. So you can actually dot then on a promise, but because I'm awaiting a promise, I don't need to do that. But what I can do is I can do a try catch block on my promise.all, and I can then just make this the put error, and log out put error, and where is that closing? Hey peep. So that needs to close there, and that will close there. And this is just indented too much. There we go. And I'm going to make it return this error. Now it's updating. And that should do it. So basically, if one of these promises comes back, rejects. Thanks, Aki. Yeah, the delay is a bit longer than that. So I've already found the answer by the time I saw the message. But thanks. Thanks anyway. Yeah, I know what the syntax is. I just always forget the, resolve reject and all the little bits and pieces because I don't use promise all that much. Switching to async await just completely has removed promises from my mind a lot of the time. But it's when you, especially when I loop through things like this, that I want to have the promise.all, because then it becomes incredibly useful, where I can do all of these, in parallel as opposed to in series, which is not the greatest. So let's go ahead and test that now in Studio, seeing as we've got all that sorted out, and send. Wait for our invocation. Ah, we're getting some data. Function is not iterable. Line 20. Let's take a peek. Line 20. I can remove that, actually. That might be why. That looks right. Yeah, this is going to return an array of promises. Or it could be a map. Now it'll return that array. Yeah, the dot each. Yeah. Okay. Just forcing it to reload. And we are all out of throat juice. Damn. If you're wondering, it's coffee. Alrighty, let's go ahead and try this again. Let's close that one. Come on, new invocation. Still function is not iterable. 20.21. Is it because I'm not doing a resolve? Okay, let me go back here. Am I being silly? Yes, I am. I don't need this. This is not what I will need. I need that's all I need. It just needs the array of promises within it. There we go. Oh. Yeah, I ended up seeing this and immediately jumped to, yeah, the wrong thing. So that's what I want, my array of promises there. Okay, it's updated. So let's try Studio again. Clear that out, send a test. Why is it not iterable? 2021. Actually, I think what I can do is set it like that and then pass it just that. That should solve. Okay, so now that I do it this way, the map will bring an array back, right? And it's returning the promise. So this should be an array of promises that I'm now passing to promise.all. Am I thinking about it wrong? That seems right to me. Unless it's some interaction with Cheerio that's causing an issue here. What I'm going to do is let me actually log this out as well. And okay. Let's see. Okay, where was I? I was looking at whether this was. I want to check. Let's see what this link is. Maybe we should rather use that. We can move off of Cheerio very quickly. This is the first time I've been using Cheerio. I've never used this module before, so for all I know, it could be doing other things that I'm not aware of. We're going to take a look at the documentation in a sec, but I believe it was doing maps as well. Yeah, I'll go take a look, see how it was doing that. It could be passing this here, and I'm doing it wrong. Okay, let's update the scraper. Let's clear that and send again. Maybe it's not actually pulling things out into an array. That could be it. Although now this has taken a long time to come back with data, so this may actually be writing stuff into DynamoDB. Let's go take a look. Is there any details? Response? No. So blank response. Let's go take a look. Okay, so it's different. That's a good sign. We may not have the error anymore. So let's go take a look at the log. We're waiting for the most recent one at 0137 or 38. This takes about as long as it takes CloudWatch to update the log, so we just have to wait for it to update here. Come on, come on. There we go. Let's take a look. Oh, it hasn't written anything to DynamoDB, so there is a problem there. Alright, that's why it took a bit extra longer, because it's actually linking this out. It's actually... Alright, so each one of those is an individual... Alright, so that does give us the right data. Oh, and link is just the index. That's all. That's what that gives us. Okay, so now I understand what it's doing. But okay, so it actually printed each one out. Did it write it to a database? Yes. Okay. It wrote stuff to our database. Awesome. So it wrote stuff to our database. Yay! Now it's working. I'm not sure why I'm not seeing the spans. Maybe that's just oh, I know why. It just takes a bit of extra time. So what we have is there's spans information that it gets added in here, but I think this takes a bit of extra time to process in. Should be showing us our calls to DynamoDB. So let's just refresh that to see if it's got that updated information. I'm afraid after this I'm going to have to call it here. Thanks, Zaki. Throat is getting scratchy, and I've just come off of a pretty nasty cold. Yeah, so why is it not showing us the rest of the spans information? I need to figure that out. Anyway, so what this has done is it has written to DynamoDB, and now we've got this huge list of stuff to go through. But I think the series essentially has ended at a point where the rest of it is kind of almost self-explanatory. This is where now the the rest of the close that. The start scraping thing can now this specific function can now actually go through that same table that we just wrote URLs into and pull whatever the batch size is here. So there's a scraper batch size as an environment variable we set, and that's set as a param from our Dynamo our dashboard. So we can control the batch size externally from our service all the time. You just if you change the param, you just do a deploy, and now it's going to use the new batch size, which is pretty cool. We have this will now pull whatever the batch size is. Our default is 1. So when it pulls that, it will then you can add the logic in here very easily to pull 1 whatever the batch size is out of DynamoDB and pull that number of records out, and then loop through the results and push each one individually as a message into SNS. And that would mean that if you had a batch size of 5, for example, you would have 5 scraper functions running in parallel that'll each go okay, I'll mention that. How it will. Okay. So the idea is that now each scraper is individually going to scan a page because it's got a URL. The idea is that the internal. Okay, so the what Zaki's mentioning is we are now storing a bunch of URLs, and most of them are internal because they're referencing internal documentation to the same page. But there are some external ones as well. Now what? If you just write those in, you've completely lost the context when you read them into start scraping. So if you read a local URL, there's no, you don't know which page, which path or absolute URL that references. So instead, what you will probably do here is you're going to add here before you put this item into there. You'll need to determine whether this is a local URL or not. So for example, you already know what this URL is here. You'd need to pull the domain portion of that the URL out, and then do a contains essentially, or check whether the this string here has that or not, or even if it just has HTTP. I guess it's an easy way to do it, HTTP or HTTPS on the front. If it doesn't have HTTP or HTTPS in the front, you know it's an internal URL, and then you just concatenate the domain on before you write it into the database, so that your URLs are always going to be absolute URLs as opposed to relative URLs to the domain. That way you're always able to pull the right page out. The other alternative is to have a separate column potentially to store domain in. That is one way to do it, but that makes things slightly more complicated in that you need to change your URL key, because now your URL key may no longer be unique. Your URL key will only be unique if you have domain and path, because that's always unique. That's how the web works. But if you are storing relative paths, any other page could have the same relative path. /docs is not a very uncommon path. So you probably, with the current DynamoDB structure, you probably have to attach the domain in front of the path in order to handle that uniqueness, and then so that the scraper can always pull up the right page. Yeah, and that's really the best way to handle that in this case. Otherwise, you're going to have a primary and secondary key. The primary key being the domain probably, and the secondary key being the path in it. That's one way to handle that separately, so that you can then go through domain. And that's actually a pretty cool way to do that, because you can always have your range be the path, the primary key be the domain, and that means that you can always go scan an entire domain. You can put an entire domain in just by querying on the domain name, and you pull all the paths in that you've got stored to loop through and go re-index and query and so on. The next step would have been as well for the indexing here to go through this heading text. And as our little front end in part 2 that we were working on showed, is that really our limited example of a search engine was to have up to 3 word phrases that you could search. And what you want to do here is you want to grab the heading text and break it down into 3-word combinations. So off the top of my head, I mean, there's so many ways you can jumble around the words inside a heading. And this is why I picked a heading, because normally there aren't very many words in a heading. But you could store the first 3 words and just essentially loop through the structure, the words in that heading, and store them in different ways so that it would match on a result. And there's a bunch of other things here that other folks have mentioned in the comments of the previous videos. One of the downsides of our previous structure, and Zaki mentions, maybe split the URL and text extraction via DynamoDB streams. That's definitely a possibility to do that. Ultimately, the idea here was that when DynamoDB, when you stored the URL storing, okay, so to go back to backtrack, the URL storing is exclusively for the Spider service. The Spider service uses the URLs table, so it knows which pages to go get and to scrape. But the actual content, the searchable content that you would index out of, for example, the headings here, and you might expand this in the future. You might choose heading 2s, heading 3s. You might choose links as well. The URL itself might be something that you index. You might go through paragraph text to paragraph DOM elements to index some of the content out of paragraphs and so on. But ultimately, they would need to resolve into actual keywords that would match. And in our case, we were using DynamoDB as an engine for matching that. And the idea with that was that every time we had a potential keyword matching sequence to this URL, we would send the URL and the keyword by SNS back to the query service here. And the query service has its own table to store keywords. So here's the keywords table. And the idea here is the query service is searching through its local DynamoDB table to match the keywords that you've been searching on in the text box. Whether or not this specific format is any good long term in production, you'd need to test that out. But the entire idea, and to wrap up this whole series, the entire idea behind structuring it with these various services is a way to demonstrate that doing this gives you some level of abstraction away from depending on services. So what I mean by that is, if you realize that your Spider service isn't doing the best job of extracting and scraping and pulling indexable data out, you can go change that. The query service doesn't care. The query service just needs to keep receiving its data so that it can continue to provide that in some way. And Zaki just pointing out that there's a 400 kilobyte limit on DynamoDB. That's on DynamoDB items. That is one of the downsides of the structure we started with in the beginning that you'd need to consider. You might need to look at having secondary indexes that helps break that up to some degree. Find some way to just split that up and have compound indexes that are more unique so that you don't hit that 400 kilobyte limit that he's pointing out. Because the original design was that it would list every what am I thinking? Trying to get across the 3 keyword idea would then have another column that has an array of domains, and that array of domains is what you give as the result of the search. So it was the DynamoDB search was meant to be very, very simple. Really, all it did was go to DynamoDB and look for the 3 words that matched and return the list of domains inside that column. So you can see here. It's actually very difficult to describe because it's really so simple here. It doesn't actually make it very clear here that that's what is happening. But here it's basically pulling out the URLs out of every result and just sending that back. So that ultimately wouldn't work. I mean, if you ended up having something like 600 domains on the same 3 keywords, you'd hit the 400 kilobyte limit probably. So you'd have to find some way to make each item unique. Other things to bear in mind. Okay, so the other side of this is that, again, because of the way we're separating out a front end, a query service, and a spider service, again, if the spider service is fine and our front end is fine, but our query service is not doing the greatest job and we want to change that, well, because all you're doing is you're sending potential indexing data via something like SNS, you could use Event Bridge instead, you could use SQS instead, you could even use Kinesis if you have enough volume. Kinesis might be a good option instead. The query service could be anything. The front end doesn't care what the query service is actually doing. The front end only cares that there's an endpoint for it to send a request to and to receive a response back from to display on the screen. Your query service backend could be Elasticsearch, it could be Algolia, it could be, I don't know, MySQL, it could be S3, it could be anything that you want it to be. But because we've structured things as front end, query service, spider service, each is its own domain that is managed separately and doesn't care necessarily about the internals of any of the other services, which makes it a lot easier for you to go in and change things out. That is a real advantage of breaking things up into these smaller services that have very specific jobs and then communicate in ways that are completely unrelated to the actual internal workings. And that's the only dependency as well. As you know, you could go change the entire internals of the spider service, but as long as it continues to send the same data structure the same way through the SNS topic, the query service doesn't care. The front end doesn't care what the query service is doing, as long as the responses that it comes back with is a body with items structured in a very specific way. That's it. So it's a very nice, clean way to keep these things separated. Unless there's any other questions. If there are any other questions, feel free to hit me up on Twitter if anybody needs to ask me more questions about this kind of work and potential for this. You could also just ask in the comments on YouTube as well if you prefer. But with that, I'm going to call this series complete for now. We will probably start a new Serverless Live series coming up, and I'm kind of excited by the idea of doing a a gaming experiment, a very simple game. I still need to come up with a concept and what we can do. We can't do anything too complicated because this isn't about necessarily building the full application. This is about getting an idea out that just shows how to build things using serverless. And with that, thank you very much. Thank you for folks who have been watching since the beginning, and I look forward to doing the next one next time. Goodbye.